Today we'll discuss ISI's BStat BMath 2022 UGA paper, and the first question is, we have expressed any positive number in the powers of. So here what we're going to do is, we are going to convert a positive real number into binary equivalent. Now here the number given is 21.1875 and we need to find the smallest positive integer case such that a minus k is unequal to 0. Now a minus k, it comes with decimal powers. So in this case, we just have to consider its decimal part. Now this decimal part is 0.1875. Now if we multiply it with 2, we'll get this as 0.375. Now integral part is 0. So for this number, after the decimal, we'll have 0. Now again, we'll multiply this 0.375 with 2. Now it will be 0.75. Again, we have 0 here. So it will again be 0. Now we'll multiply this 0.75 with 2. Now here we'll get this as 1.5. So now we have 1 here. So after the decimal, the first non-zero number, it occurs at this third position. Now this is a minus 1, this is a minus 2, and this is a minus 3. So the smallest positive integer k for which a minus k is unequal to 0 is 3, and that's your option A. Now the second question is, for some theta lying in the first quadrant, we are given that cos 3 theta upon cos theta, it is 1 by 3. Then we need to find the value of cot 3 theta into tan theta. Now we know that cos 3 theta is 4 cos cube theta minus 3 cos theta upon cos theta, and this value is 1 by 3. Now we can write this as 4 cos square theta, and here will be this 3 plus 1 by 3, which is simply 10 by 3. Now we can write this as secant square theta equals 6 by 5, and secant square theta is 1 plus 10 square theta. So we'll get 10 theta as 1 by under root 5. Now here we need to find the value of cot 3 theta into tan theta, or we can write this as tan theta upon tan 3 theta. Now this is tan theta. Now we can write tan 3 theta as 3 tan theta minus tan cube theta upon 1 minus 3 tan square theta. Now we'll cancel this 10. Here will be this 10 square. So it will be this 1 minus 3 tan square theta upon 3 minus tan square theta. Now tan square theta is 1 by 5. So it will be this 1 minus 3 by 5 upon 3 minus 1 by 5. Now this is 5 minus 3, 2. And this is 15 minus 1, 14. So this value is 1 by 7. And that's your option D. Now this third point is, the locus of point z in the complex plane satisfying z square plus mod of z square equals 0. Now we know that mod of z square is z into z bar. So we can simply write this as z square plus z bar equals 0. And we'll take this z common. So it will be z plus z bar and it will be equal to 0. Now either we'll get z equals 0 or we'll get z is equal to minus z bar. Now when z is minus z bar, it means it is purely imaginary. And z is equal to 0 is the origin, which will also lie on this line. So locus of point z will be a straight line, and that's your option A. Now here the question is, among all polynomials, px equals c0 plus c1x up to c10x to the power 10 with real coefficients satisfying mod of px is less than or equal to x, for all x belongs to minus 1 and 1, what is the maximum possible value of 2c0 plus c1 to the power 10? Now, clearly it is true for all x lying between minus 1 and 1. So if we put x as 0, we can write mod of p0, it will be less than or equal to 0, Now since modulus cannot be negative, so we'll get this condition that P0 is 0. Now P0 is nothing but C0. So from here we'll get this condition that the value of C0 is 0. So here we'll put C0 as 0. So this expression reduces to C1 to the power 10. Now we need to find maximum possible value of C1. Now we are given that mod of Px is less than or equal to x. Now in this case, mod of Px will be mod of C1x plus C2x square up to C10 x to the power 10, and it should be less than or equal to mod x. Now basically it'll be graph of some polynomial and this is graph of mod x. So modulus of this polynomial function is less than mod x, that is modulus of graph of this function should always lie below the graph of mod x. Now if we look at mod x, this is the mod x function, and this function on the left, its value should somewhere lie below this graph. Now if we consider maximum value of this function, maximum value of this function will be when it is along this line. So that is the maximum possible value for this function. That means this coefficient of x, which is C1x, and this mod of C1x, it will always be less than or equal to x. From here we'll get this condition that mod of C1 is always less than or equal to 1. Now here maximum possible value of C1 is 1. Now we take the maximum value of C1, this value will be simply 1 to the power 10, which is 1. So answer to this question is this option D. Now in question number 5, we are given that fx into fy is equal to fx plus y plus fx minus y for all xy belongs to z, and if f1 equals 3, then find the value of f7. Now before that, what we'll do is we'll find the value of f0. So we'll put x and y both as 0, then we can write this as f0 square will be equal to 2 times f0. So from here we get two possibilities, either f0 is 0 or f0 is 2. Now if we take f0 as 0, then this function will be a constant function whose value is throughout 0. But we are given that f1 equals 3, so that means we have to discard this case. So from here we get this condition that value of f0, it is 2. Now we have the value of f1 and we have the value of f0. So we'll find the value of f2, and for that we'll put both x and y as 1. Now if we put x and y as both 1, so we'll get this as f1 square, and it'll be equal to f2 plus f0. Now f1 is 3. Now 3 square is 9. 9 minus 2 is 7. So from here we'll get the value of f2 as 7. So we have the value of f2, which now is 7. Now using f1 and f2, we'll find the value of f3. Now we'll put x as 2 and y as 1. So it'll be f2 into f1, and it'll be equal to f3 plus f1. Now f2 is 7, f1 is 3, so it'll be 21. 21 minus 3 will be 18. So value of f3 will be simply 18. Now we'll find f4, and for f4 we'll put x and y as both 2. So we'll get f2 square, and will be equal to f4 plus f0. So from here we can write f4 as, now f2 square is 49. 49 minus 2 is 47. So value of f4 is simply 47. Now once we have f3 and f4, we can find f7. So we'll put x as 4 and y as 3. So now here will be f4 into f3, and it will be equal to F7 plus F1. Now F4 into F3 will be 47 into 18, which is 846, and this is F7 and F1. F1 is 3. So this value of F7 will be simply 843, and that's your option C. Now the sixth question is, if A and B are two 3 cross 3 matrices such that A plus B square is A square plus B square, then which of the following must be true? Now we know that A plus B square is A square plus B square plus AB plus BA. Now if it is given that it is equal to A square plus B square, it simply means that the value of AB plus BA, it must be 0. So there is a condition that we are getting from this result. Now which of the following must be true? Now we look at A minus B square will be A minus B into A minus B. So it will be this A square plus B square, and this is minus AB plus BA. Now we know that AB plus BA is a null matrix. So this is O. So this result will be simply A square plus B square, and that's your option D. Now the question is, if N1, N2 and N12 be the permutations of these 12 numbers with the arrangement that N1 is greater than N2 and N5 is greater than N6 and N6 is less than N7, N8 up to N12, we need to find number of arrangements. Now if we look at this N6 is the number which is less than all the numbers. So clearly this N6, it must be 1. So for N6, we have only one choice and it is 1. Now from the remaining 11 numbers, we need to choose 5 numbers for this and 6 numbers for this side. Now from these 11, we can select any 5 numbers in 11C 5 ways, and remaining 6 will be simply 6C6, which is nothing but 1. And since we are arranging them in ascending or descending order, that means they can be arranged in only one way. So total number of arrangements will be simply 11C5 or NCN minus R, which is 11C6, and that's your option C. Now the question is, the sides of a regular hexagon ABCDE is extended by doubling to form a bigger hexagon, then the ratio of the areas of bigger to smaller hexagon is. Now suppose this length is X. Now we have doubled it, so it will be this X, and this also will be simply X. Now this angle is 90 degrees. Now length of this side will be simply under root 2x square minus x square. So that will be simply root 3x. Now if we look at area of this bigger, it will be 6 times, and then we have 6 equilateral triangles. So it will be this root 3 by 4 into root 3x whole square upon, and then 6 times, and for this smaller hexagon there will be 6 equilateral triangle of length x, which will give us root 3 by 4 into x square. Now I will cancel, x square will also cancel. So ratio of area of bigger to smaller hexagon will be simply 3, and that's your option B. Now question number 9 is, in how many ways we can choose A1, A2, A3, A4 in increasing manner from numbers from 1 to 30 such that they form an arithmetic progression. Now this is a very standard question. So what we'll do is, we'll write all the cases according to common difference. Now if we choose common difference as 1, then we can choose these numbers as either 1, 2, 3, 4 or 2, 3, 4, 5, and we'll go all the way up to 27, 28, 29, 30. So from 1 to 27, we have altogether 27 choices. Now if we take common difference of 2, then we'll take these numbers as 1, 3, 5, 7 or 2468, and it'll go all the way up to, now this is 30, 28, 26 and 24. So again from 1 to 24, number of such possible combinations are 24, and it'll continue till we get common difference of, I think it'll be 9. So if we take common difference as 9, we'll get 1, 10, 19, 28, or it'll be 2, 11, 20, 29, or 3, 12, 21 and 30. So we have 3 cases here. Now if we take D as 10, then we will get 1, 11, 21 and 31. 31 is not there. So these are the all possible combinations. So total number of ways will be simply 3 plus 6 up to 27. Now this is 3. This is 1 plus 2 up to 9. So it will be this n plus 1 divided by 2. So this is 270 divided by 2, and it will be simply 135. And that's your option A. Now the next question is, suppose the numbers 71, 104 and 159 leave the same remainder r when divided by a certain number n greater than 1. Then the value of 3n plus 4r must be equal to what? Now we can write this 71 as sum an plus r. Now 104 as sum bn plus r, and 159 as sum cn plus r. Now if we subtract this first from second, we'll get 33 equals b minus an. Now from third and second we can write 159 minus 104, which is 55, and will be this c minus b into n. And from first and third we can write 159 minus 71, and will be simply 88, and that is c minus a into n. So basically n divides 33, n also divides 55, and n divides 88. So this n, it must be 11. So from here we'll get the value of n is 11. If we divide 71 by 11, there will be 66. 71 minus 66 is 5. So we'll get this remainder r as 5. So we have n as 11 and r as 5. So once we have the value of n and r, we can write 3n plus 4r as 3 into 11 plus 4 into 5. Now this is 33 plus 20. That will be 53, and that's your option A. Now the question is, if x and y are positive real numbers such that 3x plus 4y is greater than 72, then maximum possible value of 12xy into 72 minus 3x minus 4y. Now we can write this as 3x into 4y, and this is 72 minus 3x minus 4y. Now 3x, it is positive, 4y is also positive, and 72 minus 3x minus 4y, it is also a positive number. So we have 3 positive numbers, and we need to find maximum possible value of their product. Now once we have positive number and we have to find maximum value of the product, so we'll use AM and GN. So if we write their arithmetic mean will be 3x plus 4y plus 72 minus 3x minus 4y divided by 3, and it should be greater than or equal to 3x into 4y, and this is 72 minus 3x minus 4y to the power 1 by 3. Now 3x plus 4y will cancel. Now here will be 24. Now if we take this cube on the left hand side, we can write this 3x into 4y into 72 minus 3x minus 4y will be less than or equal to 24 cube. Now 24 cube is 13824. So the maximum possible value of this expression is 13824, and that's your option B. Now this we need to find minimum value of this function, which is mod of x minus 3 plus mod of x plus 2 plus mod of x plus 1 plus mod of x. Now we know that mean deviation is minimum about its median. So we need to find median of these four numbers, and the numbers are minus 2, minus 1, 0 and 3. Now since it has two middle values, its deviation will be minimum at m equals minus 1 plus 0 divided by 2. That is when the value of m is minus 1 by 2. Now if we put m as minus 1 by 2, it will be this minus 1 by 2 minus 3. So that will be simply 7 by 2 plus 2 minus 1 by 2, 3 by 2 plus 1 by 2 plus 1 by 2, which is 12 by 2, and 12 by 2 is 6. So minimum value of this function will be 6, and that's your option C. Now in question number 13, we are given this differentiable function u, which is defined in the interval 0 to 1, and which satisfies this condition that for any point A, UA is defined as this 1 upon 2r, and this integral from a minus r to a plus r, and will be this ux dx. Now if we look at this integral on the right hand side, it is nothing but it is of the form this integral from a to b fx dx upon b minus a, which is nothing but which is average value of this function in the interval a to b. So it simply means that for any point A lying between 0 and 1, value of this function is equal to average value of the function in any and every interval a minus rn, a plus r, provided r is less than minimum an 1 minus a. Now this can only be true if and only if this function, it is a straight line function, because only the straight line function average value at any interval is going to lie at its midpoint. So this point A, it is midpoint of a minus rn, a plus r. So it is only possible when this ux, it is a linear function, either moving up or moving down or a constant function. Now since it is a differentiable function in the closed interval 0 to 1, it will have a maxima, it will also have a minima, and maximum minima will be at 0 or 1. So in either case, it will attain both its maximum and minimum on the set 0 to 1, and that's your option D. Now here the question is, a straight road has walls on both sides of height 8 and 4. Two ladders are placed. What is the height h of the maximum clearance x below the ladder? Now suppose this is P and this is Q. Now in this triangle, we can write x upon 8 equals q upon p plus q, or using component dividendo, we can write x upon 8 minus x will be equal to q upon p, and that's our first equation. Then the same way for this triangle, we can write x upon 4 equals p upon p plus q, or x upon 4 minus x will be equal to p by q, and that's our second equation. Now if we multiply them, we can write x square upon 8 minus x into 4 minus x, and will be equal to 1. So we'll get x square equals x square minus 12x plus 32. Now this x square will cancel. So the value of x will be simply 32 by 12, which is 8 by 3, and that's your option C. Now here the question is, let y equals x plus c1 and x plus c2 be two tangents to this ellipse, which is x square upon 1 plus y square upon 1 by 4 equals 1, which is standard ellipse of the first form. Now, for these two tangents, value of m is 1. Now we know that equation of tangent to ellipse, it is given by y equals mx plus minus under root a square m square plus b square. Now in this case, value of m is 1. So it will be y equals x and plus minus under root of a square plus b square. Now a square is 1 and b square is 1 by 4. So this value will be simply 5 by 4. So we'll get two equations as y equals x plus under root 5 by 2 and y equals x minus under root 5 by 2. Now we get C1 and C2. If we take the difference, this value will be simply under root 5, and that's your option B. Now the question is, in the figure below, ABCD is a square and triangle CEF with given sides inscribed in the figure. Find the length BE. Now suppose this angle is theta. It's a right angle triangle, so this is 90. So it will be this 90 minus theta, and we get this angle as theta. Now this is 3 cos theta. And here this is 4. It is 90. So it will be this 4 sin theta. And this side is 4 cos theta. Now since it is a square, both sides, they must be equal. So we'll get 3 cos theta plus 4 sin theta. It must be equal to 4 cos theta, or we'll get 10 theta as 1 by 4. Now we need to find the value of BE. Now this BE is this entire length, which is 4 cos theta minus this length, and this length is 3 sin theta. Now we have this 10 theta. This is 1 and 4. Now this is under root 17. Now 4 cos theta will be 16 by root 17 minus, and 3 sin theta will be 3 by under root 17. So it will be this 13 by root 17, and that's your option A. Now here the question is, let P and Q be two non-zero polynomials such that degree of P is less than or equal to degree of Q, and P into QA equals 0 for A equals 0, 1, 2, 3 up to 10. Now for this equation, we have at least 11 real roots. Now if we take degree of Q as 5, then degree of P will also be less than or equal to 5. In that case, maximum number of roots of this equation PA into QA will be 10. But we are given that we have at least 11 real roots. That means the degree of Q, it can never be 5. So answer to this question is this option C. And question number 18, we are given this integral. So we can solve this integral as an will be 1 by under root n tan inverse under root n into x from 0 to n. So this is standard integral 1 upon 1 plus x square. So if we put the value of x, we can write this as tan inverse n to the power 3 by 2 upon under root n. Now we need to find this limit n tends to infinite an. So this is limit n tends to infinite an. Now this is tan inverse infinite, and tan inverse infinite is pi by 2 and upon infinity. Now this is finite upon infinite, which is 0. So answer to this limit is simply 0. And that's your option A. Now the question is, we are given a 3 cross magic square such that sum of 3 numbers in any row, any column, or any of the 2 major diagonals is the same. Then for the following incomplete magic square, the column sum is. Now suppose this number is x. Now if we take sum of this row, so it will be 27 plus 36 plus x, and it will be equal to 27 plus, now suppose this is y, plus 31. Now 27 will cancel. So we'll get this as x plus 5. So this number will be simply x plus 5. Now if we take sum along this diagonal and this row, we'll get 27 plus 36 plus x, and it'll be this x plus 31. Now x will cancel. Now this is 5. So this value will be simply 32. So we'll get 32 here. Now if we consider these two rows, then it will be this 27 plus 36 plus x, and here will be this x plus 5 plus 32. Now here x will cancel. Now 32 plus 5 is 37. So this is 1. We'll get this number as 26. So this number will be this 26. And now we'll take sum of this row and this column. So it will be this 27 plus 36 plus x, and it will be equal to x plus 26. Now this x will cancel. So this value will be simply 37. Now we have to find this column sum. Now we know that column sum is equal to sum of diagonal also. So this column sum will be simply 27 plus 32 plus 37, which is 96, and that's your option B. Now the question is number of positive integer n less than or equal to 22 such that 7 divides n to the power 5 plus 4 n to the power 4 plus 3 n cube plus 2022. Now if we divide 2022 with 7, we'll get the remainder 6. So 2022 is 6 modulo 7. Now if 7 divides this number, then this n to the power 5 plus 4 n to the power 4 plus 3 n cube, it must be 1 modulo 7. Now we can write this as n cube, and this is n square plus 4n plus 3. So it will be simply n plus 1, n plus 3. It should be congruent 1 modulo 7. Now we are given the value of n. It starts from 1 and goes all the way up to 23. Now what we'll do is we'll try and find the solution between 1 and 7. So the possible values are 1, 2, 3, 4, 5, 6 and 7. Now clearly 7 is not possible because then we'll have remainder 0. Now 6 plus 1 is 7. So 6 is also not possible, and 4 plus 3 is 7. So it is also not possible. So out of these 7, we have eliminated 3. Now if we put n as 1, we'll get this as 1. This is 2 and 4, 8. And 8 is congruent 1 modulo 7. So one of the solution is n equals 1. Now if we take n as 2, we'll get this as 8. 8 into 3. 8 into 3 into 5, which is 15. Now 15 into 8 is 120. And 120 again is congruent 1 modulo 7. So we'll have n equals 2 also. Now if we take n as 3, we'll get this as 27, and this is 4, and this is 6. Now 27 is 6 modulo 7. Now this is 36. 36 is 1 modulo 7, and 1 into 4 is 4. So this is congruent to 4 modulo 7. So it is not 1. So we will not consider 3. And what about 5? 5 is 5 cube into 6, and this is 8. Now this is simply 6,000, which again is 1 modulo 7. So out of these 7, we have only 3 possible candidates, which are 1, 2 and 5. Now considering again from 8 to 14, now this 8 is again 1 modulo 7. So 8 is similar to that of 1, 9 is similar to 2. So here again we'll have 3 values. So we have 3 values here, 3 values here. And from 15 to 21, we have 3 more values. Now what about 22? Now 22 is again 1 modulo 7. So we'll have this one more case when n is 22. So total number of cases will be 9 plus 1, 10. So number of positive integers n will be simply 10, and that's your option D. Now the question is, in a class of 45 students, 3 students can write well using either hand. So we have this Venn diagram where we have left, right, and then there are 3 of them which are deft in both the hands. The number of students who can write well only with right hand is 24, more than number of those who can write well with left hand. Now suppose only with left is x, then this is x plus 24. Now total number of students is 45, and these 45 students, they can either write from left or right or both. So that means this x plus 3 plus x plus 24, it must be equal to 45. Now this is 2x equals 45 minus 27, which is 18. So value of x is simply 9. Now it is asking for number of students who can write well with right hand. Now total number of students who can write well with right hand is x plus 27. So it will be this 27 plus 9, which is 36. And that's your option B. And question number 22, it says, if 1 omega and omega square be cube root of unity, then this product is equal to what? Now we know that 1 plus omega square is minus omega. So it will be this minus 2 omega. And here 1 plus omega to the power 4. So it will be this 1 plus omega. And 1 plus omega is minus omega square. So it will be this minus 2 omega square. Now in the same way, this is a 1 minus omega. And this is omega to the power 8, which is omega square. So it will be same as this first expression. And the next one will be same as this second expression. So again, we'll get minus 2 omega square. And we'll continue getting these same pairs. Now it starts from 2 to the power 0 to 2 to the power 9. So that means we have 10 expressions. So we have 5 such pairs. So it will be this minus 2 omega into minus 2 omega square to the power 5. Now omega into omega square is omega cube, which is 1. And this is 2 square to the power 5 is 2 to the power 10. So value of this expression is 2 to the power 10. And that's your option A. Now the question is, this function x square into ln x in the interval 0 to 2 has. Now if this is fx, which is x square log x between 0 to 2, we'll differentiate this to find its critical points. So we'll get x square log x is simply 1 by x and then plus 2x log x. Now x and x will cancel. So we'll get this as x, and it will be this 1 plus 2 ln x equals 0. So from here we get either x as 0 or x as e to the power minus 1 by 2. Now x equal to 0, it is not included. So the only critical point that we have here is e to the power minus 1 by 2. Now rightmost is plus and the leftmost is minus. So basically it is a point of local minima. So we'll have exactly one point of local minimum and no point of local maximum, and that's your option B. Now here the question is, number of possible triplets A, B, C such that A is less than B is less than C, such that 1 upon A plus 1 upon B plus 1 upon C is equal to 1 plus 2 upon A, B, C. So we have to find number of such triplets. Now we simplify this, we can write this as AB plus BC plus CA will be equal to simply ABC plus 2. Now we have this standard result that A minus 1 into B minus 1 into C minus 1 will be equal to ABC minus AB minus BC minus CA plus A plus B plus C and then minus 1. Now we know that AB plus BC plus CA is equal to ABC plus 2. So basically ABC minus AB minus BC and minus CA, this value will be nothing but will be minus 2. So we can write this as A plus B plus C minus 3, or simply A minus 1 plus B minus 1 plus C minus 1. So the result that we have here is A minus 1 into B minus 1 into C minus 1, it is equal to A minus 1 plus B minus 1 plus C minus 1. Now clearly one of the solution is when all ABC they are equal to 1. In that case, left hand side is 0 and right hand side is 0, but we are given that A is less than B is less than C. So we'll discard this solution. So what we'll do is we'll take this as capital A, we'll take this as capital B, and we'll take this as capital C. So we can write this as ABC and it will be equal to A plus B plus C. Now we can write this as B plus C and it will be equal to A into BC minus 1. And since A is greater than or equal to 1, so it will be greater than or equal to BC minus 1. Now if we take everything on the left hand side, we can write B plus C minus BC and it will be greater than or equal to minus 1. We'll subtract minus 1 from both sides. So we can write B minus BC plus C minus 1, it is greater than or equal to minus 2. Now if we multiply it with minus sign, then we can write this as B minus 1 into C minus 1, it is less than or equal to 2. Now this product, it cannot be 1 because in that case we'll have B equals C, but we are given B strictly less than C. So the only possible option is this product, it must be equal to 2, and it is 2 if this value is 1 and this value is 2. So from here we'll get B as 2 and C as 3. Now B is B minus 1. So small b is 3 and C is C minus 1. So value of small c is 4. Now if we put the value of B and C here, we'll get 6A and this is equal to A plus and B plus C is 5. So value of A will be 1, and if A is 1, so value of small a will be 2. So the only possible solution to this equation in case ABC are unequal is 2, 3 and 4, and that's your option C. I think this problem is probably Bangladesh Regional Olympiad problem. Now here the question is, an urn contains 30 balls out of which one is special. If 6 of these balls are taken at random, find the probability that special ball is chosen. So total number of cases is 30C6. Now from these 6, one must be special. So it will be 1C1 and then we should take any 5 out of 29. So it will be this 29C5 upon 30C6. Now this is factorial 29 upon factorial 5, factorial 24, and this is factorial 30, factorial 6 and factorial 24. Now I'll cancel. Now this value will be simply 6 by 30, which is 1 by 5, and that's your option C. Now here the question is, a triangle has sides of length root 5, 2 root 2 and root 3. Then the radius of inscribed circle is. Now if we look at root 5 square plus root 3 square, which is 8, and it will be equal to 2 root 2 whole square. So basically it is a right angle triangle. Now this is root 5, this is root 3, and this is 2 root 2. Now we know that if it is a right angle triangle and we have these sides A, B and C, then A square plus B square equals C square, and we know that R is simply delta upon S. Now delta is area of this triangle, which is half AB, and S is A plus B plus C whole divided by 2. Now this 2 and 2 will cancel. So this is AB upon A plus B plus C. Now what we'll do is we'll rationalize it with A plus B minus C. So it will be A plus B minus C. So we can write this as AB and this is a plus b minus c, and this is a square minus b square, which is a square plus b square plus 2ab and then minus c square. Now a square plus b square is c square, so it will cancel. AB will also cancel. So this result will be simply a plus b minus c upon 2. So radius of in circle of a right angle triangle will be a plus b minus c upon 2, where c is hypotenuse. So this result will be this root 3 plus root 5 minus 2 root 2 upon 2, and that's your option D. Now the question is, two ships are approaching a port along a straight routes at constant velocities. Initially, the two ships and the port formed an equilateral triangle. After the second ship traveled 80 km, the triangle becomes a right angle. Now when first ship reaches the port, the second ship was still 120 kilometers from the port. Find the initial distance of the ships from the port. Now let this distance be D. Now this is D. Now when this first one, it has moved 80 kilometers, it becomes a right angle triangle. Now this distance, it is D minus 80. Now this angle is 60. So this side, it will be simply D minus 80 cos 60, which is D minus 80 by 2. Now this entire length is D because it is an equilateral triangle. So this length will be D minus 80 by 2. So which is D plus 80 by 2. Now suppose speed of this ship is V1 and speed of this ship is V2, and time taken here is suppose T1. Now from here we can write V1 T1 will be equal to D plus 80 by 2 and V2 T1 will be simply 80. Now it says when the first ship reaches the port, the second ship was still 120 kilometers behind. So this second ship will be 120 kilometers behind. So basically distance covered by this second ship in the second time T2, it will be D minus 80 minus 120, and there will be simply D minus 200. So first ship, it has covered D minus 80 by 2 and the second ship has covered D minus 200 kilometers. Now V1 T2, it is D minus 80 by 2 and V2 T2 will be simply D minus 200. Now from this question we need to find the value of D and we have to eliminate V1, V2 and T1, T2. So what we'll do is we'll multiply them together. So we'll get V1, V2, T1, T2 and we'll multiply them together. We'll get V1, V2 and T1, T2. And if we equate them, we'll get D plus 80 by 2 into D minus 200 and will be equal to 80 into D minus 80 by 2. Now this 2 and 2 will cancel. So we'll get this as D square and then this is minus 120D minus 16000 and this is 80D minus 6400. So it will be this D square minus 200D minus, and this is 16,000 minus 6400, which is minus 9600. Now we solve this quadratic equation, we get value of D as either minus 40 or value of D as 240. Now it cannot be negative. So distance between these two ships initially is 240 kilometers and that's your option A. Now here the question is, if x1, x2 up to x10 are real numbers, then what is the least possible value of, now this is x1 minus 10, x1 minus 10, x1 minus 10, 9 times, so it will be this x1 minus x10 to the power 9 upon x1 minus x2, x2 minus x3 up to x9 minus x10. Now since they are in descending order, each of these numbers, they are positive. So basically we need to find relationship between product and sum of these numbers, and for that we can simply use AM and GM. Now if we find arithmetic mean of these 9 numbers, so it will be x1 minus x2 plus x2 minus x3 up to x9 minus x10 whole divided by 9 will be greater than or equal to x1 minus x2 into x2 minus x3 up to x9 minus x10. Now here all these numbers they'll cancel, so we'll get x1 minus x10 upon 9, and this is whole to the power 1 by 9. Now if we take 9th power, then we can write x1 minus x10 to the power 9 upon 9 to the power 9. It is greater than or equal to x1 minus x2 into x2 minus x3 up to x9 minus x10. Now we rearrange this expression, it will always be greater than or equal to 9 to the power 9. So the least possible value is 9 to the power 9, and that's your option C. Now this 29th question is fairly simple. It says find the range of this function over all x. Now we can write this as fx, and it will be equal to x square plus 2x. We'll add 1 and subtract 1. So we can write x plus 1 whole square plus 3. And here if we take 2 common, we can write 2. And again we can write this as x plus 1 whole square plus 2 minus 2, and that will be simply 7. Now say this is equal to y. Now we cross multiply, we can write x plus 1 whole square plus 3, that is equal to 2y into x plus 1 square plus 7y. Now we can rearrange this as 1 minus 2y into x plus 1 whole square, and it will be equal to 7y minus 3, or it is x plus 1 whole square equals 7y minus 3 upon 1 minus 2y. Now basically x plus 1 whole square, it is always greater than or equal to 0. Now if we solve this rational inequality, we'll get 2 roots. Now this is 3 by 7 and this is 1 by 2. Now rightmost is minus, this is plus, and this is minus. We need plus. We'll include roots in the numerator and we'll exclude this root in the denominator. So range of this function y, it will lie between 3 by 7 and not included 1 by 2, and that's your option B. Now the next question is, in the following diagram, 4 triangles and their sides are given. Area of 3 of them are also given. Find the area of the remaining triangle. Now we are given this first triangle whose sides are A, B and 6. So we'll draw this triangle. So this is A, B and 6. Now what we'll do is we'll join this side with this given side. So we can write this is what we'll do is we'll join these 2 triangles with the common side B. So it'll be this side BC and it is 6. Now we'll join this common side C. We'll have this side 6 and this is D, and then we have this triangle with common sides AD and this is 6. So basically it will form a rhombus. Now we know that in a rhombus, distance between any 2 parallel sides is same. So basically sum of areas of opposite triangles, it must be same. Now we are given that area of this first triangle is 4. Now for BC it is 5. Now for CD it is X, and for DA it is 13. So sum of areas of the opposite side, it is 13 plus 5, and it must be equal to X plus 4. So basically value of X, it must be 14, and that's your option C.